A rectangular poster is to contain 722 square inches of print. The margins at the top and the bottom should be 2 inches, margins left and right 1 inch. What dimensions of the poster will use the least amount of paper? What should the dimensions of the poster be so that the least amount of poster is used? Okay, we need a picture. Here's my poster. This is where the ink is, or the print, and that has to be 722 square inches. Okay, and then the margins go like this. The bottom of the poster should be 2, so the distance from here to here is 2 inches, as is that. And then over here it sounds like we need 1 inch. All right, so we also need variables. So if I set it up like this, I guess you have 2 options. You could call this distance y, or you could call this distance y, or whatever variable you want to use. I'm going to go with, call that y and that x. Okay, so that means that the area, then I can directly have my secondary equation, xy equals 722. And then what I want to do is minimize the area of the entire poster, right? Minimize this by this, okay? So the algebraic representation of the width of the poster would be what I'm calling x plus this one and this one. So x plus 2, and then y plus 4, and I'll call that area, okay? So this is kind of a standard optimization problem. We have this, what we call secondary equation, primary equation. This is the equation I want to do the calculus on. I'm going to take the derivative, set to 0, make sure it does in fact give me a minimum. But first, it's a function right now of 2 variables, so I need to sub out one of the 2 variables, right? And I'll just solve this for y. And I get y equals 722 over x, and that's going right here. Okay, so I got x plus 2 times 722 over x plus 4 equals a, right? So now this is a function of x, and I can take the derivative, set to 0, do the first derivative, second derivative test to figure out if it's a minimum. But first, we probably want to avoid the product rule. So I'll go ahead and FOIL this guy and have a much nicer looking function of area. So that's 722 plus 4x plus 1444 over x plus 8. Okay, I can add these together and I'll have my area function. So area equals, let's see, 4x plus 144 over x plus 730. The derivative of that should be 4. This, remember, is 144, x to the negative 1. So it should be 4 minus 144. That should be 1444, right? 1444. X to the negative 2, derivative constant is 0. Set my denominator to 0 to find a critical number, and then solve this guy. So this is 0 equals 4 minus, I'll rewrite this as a fraction just so I can take a look. All right, how do we solve this? Well, if I just add him over, 144 over x squared equals 4, multiply both sides by x squared, and then divide both sides by 4, I get 1444 over 4 equals x squared. And if I divide 1444 by 4, I get 361. And then I take the square root, both sides. I get 19. Okay, I'm pretty happy that's right. This is a textbook problem, plus or minus 19, but we're only interested in the positive since it's a measured value. Pretty happy that's right because it's coming from the textbook, and a lot of times they like to give us these nice, not always, but a lot of times they like to give us these nice perfect squares as solutions. Okay, so that gives me x, and then we can, first what you should do is really make sure this is in fact giving us a minimum area. So we do that. We can either do the first derivative test or the second derivative test. I'll do the second derivative test, and that should be 2888 x to the negative 3, which is, if you want, and I have to make sure, remember the second derivative test. I plug in my critical number into the second derivative, and I see if I get a positive or negative. I don't care what it is. I don't care what the value is. I care if it's positive or negative. This clearly would be positive. Cube 19, and then divide 288 by that result, and everything's positive. So that's positive, which means the function there is concave up. Combine that with the fact we have a critical number here at x equals 19, then that means it's got to be a minimum. Okay, so we verified that. Now we can answer the question, what should the dimensions of the poster be? Okay, so the poster shouldn't be 19 by something. The poster, if x is 19, we got to say it should be 21 this way. And then if y equals 722 over x, then y is 722 divided by 19, which is 38. And then we know to add 2 and 2, which would give me 42. So the poster should be 21 by 42 inches.